that last quiz question that we just got done working, that was something like this. We did the limit as n goes to infinity of our sum. We had f of x sub I was when we plugged our x sub I into the equation. Change in x, right, that was the width of our rectangle. So that's exactly what we did on the last question of our quiz, finding those areas. And we know that gives us the exact area under the curve, not the over or under approximation. All right. We can also see that same thing come up if we talk about distances traveled. So we've only talked about it in the context of area, but we can see it in terms of distance. And a lot of other different situations. This thing that we've been calculating is actually referred to as an integral. So an integral is this long skinny s thing, okay? And it gives us, the definite integral has a starting point and a stopping point. So those would be on the intervals. If I said we're going from 2 to 5 or 0 to 4, that's our a and b. A is where you start, B is where you end. Of your function times dx is like the change in x. And this means, this symbol is saying the limit as n goes to infinity of the sum. The f of x and the f of x sub I are kind of the same. And dx is that change in x that we've been referring to. So we're going to take the same calculation that we have been doing, but we're using a different notation to represent that, kind of a more concise one. You know, it's a lot easier to write this little skinny S-looking symbol than it is to say the limit as n goes to infinity of the sum from I equals 1 to n. So it's just more concise. If we can find that, we say something is integrable. So we'll be talking about that a lot. So just notation things. The f of x, the function that we are integrating, is called the integrand. So the integrand is the thing we are trying to take the integral of, or it's the function we're finding the area under. A and b are called the limits of integration. A is our starting point, so it's called the lower limit. B is our ending point, so it is called the upper limit. Another thing to mention, when we have an integral, so anytime we have this symbol, I hate when my board doesn't, I have to restart my whole computer to make it. All right, this integral symbol is and the dx go together, so you can't have one without the other. So that's all that the next slide is saying. If you have an integral, the dx goes with it. All right. So in terms of what we have been talking about, when we did the limit as n goes to infinity of the sum from 1 to n, we were talking about area under a curve. So this integral is talking about the area under a curve from a starting to a stopping point. Okay? And we've talked about it in terms of over and under approximations, but we know to get the true area, that number of rectangles has to go to infinity. So that is our integral. Now, we've been looking at curves that were all above the x-axis, but is it possible for things to drop below the x-axis? So what do you think that would be due to their area? So typically, anything below the x-axis is considered a negative area. So above is positive, below is negative. And so when we find the integral, it's actually giving us what's called the net area, which is like the positive minus the negative. So it's possible that we might have a curve with an area of 0, meaning they're equal parts above and below the x-axis. It's also possible that we could get an area that is negative at the end, meaning that there is more below the axis than above the axis. All right, so just a couple of theorems. If you have a continuous function or a function with just a set number of jumps in it, then we can find the integral. So it will exist in those cases. And if there is an integral, we can do it by the same calculation that we were doing before. The limit as n goes to infinity of the sum from I equals 1 to n of the f of x sub I times our change in x. So let's do one. Alright, if I am asking you to find this integral, the only way we know to do this right now is like we were doing on our last homework assignment or that last question on the quiz. So I need a change in x to do that. How do we find our change in x? So we're stopping at the top, so it's top minus bottom divided by n. So 4 over n. Alright, then we need our x sub I. X sub I is your starting point, which was 0, plus the change in x times I. So we get 4 over n I. So the rule, we're trying to find this integral. So we do it by doing this. The limit as n goes to infinity of the sum from I equals 1 to n f of x sub I, which is what you get if you plug your x sub I into the x's of your function. So 4 over n I cubed minus 2 times 4 over n I times our change in x, or like that dx, they mean the same thing, so that is just the width of our rectangles. So times our 4 over n. Alright, same thing we have been doing, I just kind of wrote it out all in one step. Have I lost anybody? So if I want to do my summation, what do I need to do? We've got to simplify this first. I cube this, 4 to the third, 64 over n to the third, I to the third, minus 8 over n I, and this is all times 4 over n. So if I distribute my 4 over n, 64 times 4 is 2 over n to the 4th, I cubed, minus 4 times 8 is 32 over n squared, I. I don't know, did I give you guys a blank slide after this one? Have a little more space? Okay. Alright, we've cleaned it up enough that now we can do the summation piece. Once we add it up, so once we use our summation rules, that sum symbol goes away. The 256 over n to the 4th, it's not added, it is multiplied, so it's just a coefficient that stays. Times, what is my I cubed formula? N squared times minus 32 over n squared times, what's my I formula? Show as much work as you need to for simplifying this. That's really where the mistakes happen on the quiz, just skipping too many steps and making silly mistakes. So I could do some basic, like 256 over 4 would turn into 64. I'm going to cancel 2 of those n's right off the bat. So this would be 64 over n squared times n plus 1 squared would be n squared. Let's do n plus 1. I already canceled that denominator. Over here, 32 over 2 is 16. I could cancel one of those n's. Oh yeah, you can do as much as you want. I'm just trying to show you the work here. Okay, so if I distribute 64 n squared over n squared would turn into 64. Okay, 64 times 2n would be 128n over n squared. That would be 128 over n. 64 times 1 is 64 over n squared. Minus, based on this one, 16n over n is 16, and 16 over n. Have I lost anyone there? So my whole goal is to be able to evaluate this limit. Remember, n is going to infinity. So if you have a number divided by infinity, what will that always turn into? 0. So just a constant won't change. So this is 64 plus 0 plus 0 minus 16 plus 0. So 64 minus 16 is 48. So we just evaluated our first integral. And we did it by first rewriting it using the notation that we've already been doing and using our summation rules. Questions there? Am I even asking you to calculate anything? No. I'm giving you a problem like we've seen before, a little bit different, and asking you to write it as an integral. So that integral is like a tall, skinny s. What's my lower limit? -3. It's your starting point. And my upper limit is my ending point, which is 2. Okay, so this symbol really takes care of the limit and the sum part. This, we have 2 minus 3, and then you have x sub i's. Remember, when we took our limit and wrote it, we replace the x with the x sub I. So if we're writing the integral, this just turns back into a normal x. Okay, we don't even care about the subscript. It doesn't matter if it's x sub I minus 1 or x sub 1/2 I. It doesn't matter at all. Just turns back into our x. And the change in x is the same thing as what? Dx. Every time you write an integral, it has to have a dx. Right, so we're just trying to get comfortable with the two notations and going back and forth between them so if I ask you to evaluate this integral from 2 to 5 of 3x squared plus 4 dx. What is my change in x? So it's the upper minus the lower, ending minus beginning, divided by n. So that's 3 over n. What is my x sub I? Your starting point plus change in x times I. Unfortunately, since this one didn't start at 0, it's going to make our problem a little bit uglier as we go through here, because our change in x has multiple terms with it. All right, so if I want to rewrite this, the integral means the limit of the sum f of x sub I means you go to your expression and we replace the x's with our change in x, which is 2 plus 3 over n I squared plus 4. And dx gets replaced with what? 3 over n. Now it's like a problem we were doing several days ago. A lot of algebra here. The more you show, probably the less likely you are to make a mistake. Where would we have to begin? Squaring that. Okay, to square means we have this written twice. 4 plus 6 over ni plus 6 over ni, so 12 over ni. Distribute my 3, we get 12 plus 36 over n I plus 27 over n squared I squared. And so have that plus 4 on the end. And if you guys don't need to show as many steps, that is totally up to you. But I just think that might help us with some of our mistakes if we show a little bit more. Okay, now I need to distribute my 3 over n. Can I go ahead and combine those like terms? 12 plus 4 is 16 times 3 over n. So it would be 48 over n. Plus 36 times 3. So all of that is just algebra. What is the next step? The summation. Yeah. So once I do my summation rules, that symbol will go away. So 48 over n. It's its own term and it does not have an I. That means it's a constant. So when I add that up, what do I have to do to it? Times n. 108 over n squared, that's coefficient. And what's my I formula? 48 divided by n times n is 48. 108 divided by 2 is 54. You can cancel one of those n's. Here, 81 over 6. What I do is I can cancel one of those n's. 54. Notice good notation, I'm writing my limit on every step. Okay, if I distribute, I get 54n over n, so that's 54. Plus 54 over n. Okay. This one. 27 times 2n squared. So 54n squared over 2n squared would turn into 27. 81n over 2n squared. 1 over 2n. 27 over 2n squared. Did I lose anybody on that step? I kind of did combine a couple things there. So I was multiplying out and I did reduce my fractions at the same time. Now what? If I plug in my infinity, the coefficients stay. Anything with an n on the bottom is going to 0. So I have 48 plus 54 plus 27. So 129. That one was significantly uglier because my interval didn't start at 0. That makes it a little more nasty. All right. Any questions on that problem? Yes.
So the lower limits are shown, the limits that
Mm-hmm.
and then she divides its top and its bottom.
Yes. Yes.
And then 2x is the same as your 2x.
Yes. Last example of the day. Can you write this as an interval for me? So you're not evaluating anything, just writing an interval. So it would be the integral from where to where? From 0 to pi. What's my function? Basically just ignore the x of i's, and instead of change of x, we write dx. Is that all good? We're stopping here.